So in this section, we'll be dealing with conservation of momentum in 2 dimensions. Everything up until now had just been 1 dimension, so now we're going to add a level of complexity to it that way. So what we have is a 38 kilogram child standing on a 43 kilogram raft. It's drifting with a velocity of 1.1 meters per second north relative to the water. Then the child starts moving at 0.71 meters per second east. And what that's going to do is it's going to cause the raft to move as well. So we need to determine the initial momentum of this raft, as well as how much momentum the child adds to it by walking, and then deal with that. We do have compass directions on this question, so we will need to deal with that. Remember, we have compass this way. And in 2-dimensional momentum or 2-dimensional anything related to physics, it's always good to draw a diagram. So what is happening is we have the raft drifting to the north and then the child walking to the east. What that will do is that will actually cause the momentum of the raft to now be in this direction. So we need to know momentum 1 of the child on the raft standing there drifting. We need to know the second momentum that the child adds to it, and then we can go about finding that final angled momentum. So to find the first momentum, as we have before, P equals mv. Find the momentum. We need to take into account whether we're talking about the mass of the child, the raft, or both. And because in this piece the child is standing on the raft, we need to actually account for both of their masses. So 38 kg plus 43 kg, 81, times the speed at which the raft is going north, which is 1.1 meters per second. Multiply that out, we get 89.1 kilogram meters per second, and that is in the north direction. The momentum of the second piece, now it's the child walking, and because it's the child walking against the raft, we only need to take into account the mass of the child, the 38 kgs. The child walks at 0.71 meters per second east. Multiplying that out gives us 26.98 kilogram meters per second in the east direction. Now at this point we can take and combine these and find the overall momentum. We can't just add them, we can't just subtract them. Because we are looking in 2 dimensions, we do need to use Pythagorean theorem here. I'm just going to flip over to the next page to do that. So Pythagorean theorem, a squared plus b squared equals c squared. We can call a the north direction, 89.1 kilogram meters per second. B we can call east, the 26.98. And instead of calling it c squared, I'm just going to call it momentum total squared. We could have left it as c squared, but this is a little more specific. Doing the math on this, 89.1 squared is 7,938.81. 26.98 squared is 727.9204. Add those together, we get 8,666.7304. Take the square root, And because this will end up forming a piece of the final answer, we'll go to sig figs. We need 2 of them. So we are going to get that the total momentum of this system is 93 kilogram meters per second. That is not quite enough to fully answer this question. Because we are dealing in 2 dimensions, we do need a very specific direction. Saying that we're going northeast is not good enough. We need a specific angle. So I'm just going to draw out that diagram again. We had 89.1 kilogram meters per second to the north, 26.98 kilogram meters per second to the east. And what we're really concerned with the angle is this angle here. Go back to basic trigonometry, SOHCAHTOA. Looking from that angle, 26.98 is the opposite side, 89.1 is the adjacent, so tangent would be the best choice here. Notice that I didn't label 93 kilogram meters per second on the triangle. It's secondhand information, and let's avoid it if we can. So tangent equals opposite over adjacent. Opposite side here, 26.98. Adjacent, 89.1. Put that into the calculator. Remember, keep it in degree mode for this. We will get 17 degrees. Now to put this all together, we have our 93 kilogram meters per second in a direction, and again there's 2 ways you can put the direction. We could say that this is 17 degrees east of north, or if you prefer, we could say this is 93 kilogram meters per second east, 17 degrees north. But looking back at the question for just a second, we haven't actually been asked to find the total momentum. We want the resulting velocity, which I avoided speaking about until now, because in order to do anything with this, we did need to find the overall momentum, which we have here at 93 kilogram meters per second in that direction. Now that we have that overall momentum, we can go back and we can find the velocity. So same equation, but now with total momentum, which is 93. Mass, we do need to take into account both the child and the raft, so that'll be 81 kgs for M. V, we don't know. Divide both sides by 81, going to 2 sig figs. We would get 1.1 meter per second. And a direction as well, which would be the exact same as the momentum, 17 degrees east of north.